In the previous video, we asked some standard questions about an object which had been launched into the air. Let's continue this example and ask one final problem. At what time or times did the object reach a height of 12 feet? Now let's go back up to our graph and let's see if we can figure out what would be reasonable for a possible answer. Now looking at our vertical axis, which represents the height, a height of 12 feet is right around here, indicated in red. Now, looking at the graph of this object's movement, I see that this object passes a height of 12 at two different times. Once, here before it reaches its maximum height, when the object is still moving upward, and again here, after the object has reached its maximum height, when the object is moving downward. So I should expect to get two possible times at which this object has reached a height of 12 feet. One time, which looks like it's around 0.5, and one time which looks like it might be in the vicinity of, this is 1, so this might be 1.5 or 1.5. This would be reasonable for me to expect based on the graph. Now let's try and do some calculations to get the values of t which are close to 0.5 and 1.5. It says at what time or times. So it's asking about time, it's asking about t. In particular, which t value? The t value that is associated with a height of 12. In other words, a y value of 12. So in the equation that I was given, I'm going to start by taking the y value and replacing it with the given number 12 for this problem. 12 is equal to negative 16t squared plus 30t plus 2. Now once again, I have an equation, a quadratic equation in standard form, which means that probably it will be very nice for us to use quadratic formula. But in order to use quadratic formula, we need to start by making sure that one side of the equation is equal to 0. And currently we have 12 on the far left, not 0. So I'm going to start by subtracting 12 from both sides, so that I do have 0 is equal to negative 16t squared plus 30t, and then 2 take away 12 is negative 10. This is the only way to see the true value of a, b, and c for this problem. So now, using that, let's calculate the discriminant for this part of the problem, which is equal to b squared minus 4 times the a value times the c value. So in this case, we get a discriminant of 260. So let's use quadratic formula here. Quadratic formula tells us that t is equal to negative b, negative 30, either plus or minus the square root of the discriminant, divided by 2 times the a value. Now I've gone ahead and put that into the calculator, and we have attained the two t values 0.43 and 1.44. So let's go ahead and make sure that this makes sense based on what we saw in the graph. And sure enough, this does match the fact that we saw a height of 12 being reached by the object at a time of around 0.5, so that's our 0.43. And we saw it being reached again at a time which is in the ballpark of 1.5, so that's our 1.44.